This video abstract presents a summary of the article entitled "Assessing the PV Hosting Capacity of a Colombian Urban Medium Voltage Network." With the reduction in the cost of solar panels and the implementation of regulations in Latin American countries to encourage the use of PV generation, as the Colombian case, it is necessary to evaluate the grids with such distributed resources. Given the stochastic nature of PV generation and the lack of control over its location, the operation of distribution systems becomes more complex. In this way, if the network operator does not have control over the level of penetration or participation, it cannot be certain about the quality of the energy supplied, which is critical for complying with the regulations. For instance, the regulation in Colombia established that the voltage cannot surpass a 10% of variation over or below the rated voltage. Thus, to adequately limit the PV penetration level, it is necessary to analyze how much PV generation can a distribution network host without exceeding its operating limits. It means that calculating the PV hosting capacity for a distribution network is a complex stochastic problem that requires a high computational effort and does not have a unique solution. The main contributions presented in this work include the assessment of the PV hosting capacity for a real medium voltage distribution network located in Bogotá, Colombia, calculated with a methodology that captures the stochastic behavior of PV generation and power demand, using Gaussian mixture models and Monte Carlo simulation, integrating OpenDSS and MATLAB. In addition, a statistical treatment of irradiance, temperature, and demand data is presented to perform probabilistic power flow simulations every 5 minutes and obtaining the behavior of the voltage, current, active and reactive power in the grid. The medium voltage grid has 207 nodes, 173 overhead lines, 33 underground lines, one 40 MVA power transformer at the substation, one recloser located at 2/3 of the radial circuit, and 68 distribution transformers. The transformer located in the substation supplies 8 medium voltage circuits, each with an installed capacity of 3.5 MVA. For the simulation, only one circuit is modeled in detail, while the rest of the feeders are aggregated into one load connected to the substation. The estimation of the availability and variability of the irradiance was determined by means of the Gaussian mixture model probabilistic fitting. It can be observed that there is no clear trend that allows the use of traditional probabilistic fitting, while the Gaussian mixture model approach allows a more accurate representation of any probability distribution through the combination of n normal distributions. A similar approach was applied to the power demand data, and the correlation of the temperature data with irradiance was obtained by means of cubic spline interpolation. After performing the simulations, the results can be analyzed. The current in the feeder behaves similarly to the active power. When the penetration level increases, the current decreases. However, at some point, the reverse current increases. The results indicate that starting from the 30% of PV penetration, there is a latent probability of reverse power flow. Therefore, if the reverse power flow at the substation is not allowed, a PV hosting capacity of 30% can be established for the studied distribution system. It is noted that for a PV participation index equal to 25%, the voltage at the substation remains almost constant regardless of the penetration level. However, the variability of the voltage increases with the participation index. Note that for PV participation lower or equal to 75%, there is no overvoltage in the network. The maximum voltage does not reach 1.1 per unit. In the case of 100% of participation, there is a 5% probability of overvoltage occurring if the penetration is 100% as well. As expected, in this graph we can see that as the penetration and participation increase, The voltage in the nodes increases as well. The most critical scenario is when both indices are 100%, where voltages surpass 1.1 per unit. Thus, considering the regulatory limit in Colombia, the PV hosting capacity can be established at 100% of PV penetration with a maximum participation of 75% for the studied distribution grid. In this work, a method to calculate the PV hosting capacity of a medium voltage distribution network consisting of analyzing the behavior of voltages, currents, active power, and power factor while changing the PV participation and penetration was presented. The stochastic modeling of irradiance and power demand is carried out by Gaussian mixture models and Monte Carlo simulations. An interface using MATLAB and OpenDSS is employed to run probabilistic power flows and process the data. The method was applied to a study case based on a real medium voltage distribution grid located in Bogotá, Colombia. The results of the study case show that the PV hosting capacity for this grid can be established at 100% of penetration with a maximum participation of 75%. The methodology can be applied to evaluate the PV hosting capacity considering that the results depend on the structure of the grid, the solar resources, and the power demand.